All right, let's jump right in. Today, we're looking at a really cool breakthrough in how AIs can work together. We're not just talking about a bunch of models working on their own, but as one single, super smart swarm. Let's see how they pulled it off.
So let's start with this question. Imagine you had 10 different specialists. Now, what if instead of just averaging their opinions, you could actually fuse all of their raw thinking into one single, much better decision? Well, that's pretty much the core idea we're going to unpack today.
Now, the problem they're tackling here is super real, and the stakes are really high. Trying to predict how much energy a big building will use hour by hour, that's a huge challenge. The patterns are messy, schedules are always changing, the data is just noisy. But we absolutely have to get this right if we want a stable and efficient energy grid. So, how have people usually tried to solve this kind of thing? Well, traditionally, it involves what I like to call the 10 experts approach. And for our experts, we're using a specific type of AI. Those experts are called echo state networks, or ESNs. Now, you don't have to be a machine learning guru to get this. The big thing to know about them is that they are incredibly fast to train. See, most of the network is just a bunch of random, fixed connections. They call that the reservoir. The only part that actually learns anything is the very last layer, the readout, which you can think of as the network's final decision maker. So the classic way to use these ESNs as a team, or an ensemble as it's called, is pretty simple. First, you make a bunch of them, maybe 10. Then, and this is the key part, you train each one completely by itself. They never communicate, never share notes. Then, at the very end, you just take all their different answers and average them out.
And this analogy just hits the nail on the head. It's exactly like hiring 10 experts and having each one write a totally separate report. Their manager doesn't try to synthesize their findings or anything. They just staple the 10 reports together. I mean, it kind of works, but it's not a very smart way to collaborate, is it?
And that, of course, brings us to the breakthrough idea. Researchers came up with a totally new method that allows for a much, much smarter way for these AI experts to work together. We're moving from just averaging to true collective intelligence. Just look at the difference here. On the left, you've got the old way, separate models working all alone. But on the right, you see the new way. All 10 of those experts contribute their raw thinking to a single shared model. They're collaborating right from the start to find one single optimal answer. So let's go back to our analogy. In this new approach, the 10 experts don't write separate reports at all. Instead, they send all of their raw notes, all of their messy preliminary thoughts, to one brilliant manager. And that manager, that shared readout layer, is the one who analyzes everything all at once to find the single best solution.
And the researchers themselves put it perfectly. The innovation, they say, forces all the ESNs to share a single collective readout layer. That's the whole magic trick right there. Instead of 10 different decision makers, you have one, but it has access to the unique viewpoints of all 10 expert networks.
You know what the best part is? Even though it's pulling in information from 10 different places, it is still unbelievably efficient. It's what's called a one-shot training process. It's just one single, elegant math problem that finds the perfect settings to minimize the error across all the experts at the same time. You get all the power of a team without all the extra work.
Okay, so it's a clever idea in theory, but does it actually work any better? Well, this is where the story gets really, really good. The results are, honestly, just dramatic.
Check this out. When they tested this new collective method on forecasting energy use for educational buildings, it was 87.3% more accurate than the old method of training each model by itself. Let me say that again, 87.3%. That is not a small improvement, that is a massive leap forward. And it's not just about accuracy, it's also way more reliable. The model showed an 18.8% improvement in something called uncertainty quantification. So what does that mean? It means the model is much better at knowing when it's not sure about a prediction. It's better at saying, hey, I'm not so confident about this one, which for making real-world decisions is absolutely critical.
I mean, this chart says it all, right? You can just see the night and day difference. The collective training method on the right doesn't just beat the old individual method, it completely blows it out of the water. That performance gap is just huge.
So just to recap, why is this so much better? Well, first, you get way better accuracy because that single manager can smartly combine all the different perspectives. Second, it's more reliable because when you pull all the evidence together, you naturally reduce uncertainty. And the amazing part is, it's just as fast to train because it's still that single, efficient, one-shot solution.
So yeah, this is a fantastic result for anyone trying to forecast energy use. But the real story here, the implications of this idea, they go way, way beyond that. This is really about a new way for AIs to collaborate.
And here's the big takeaway. By forcing all these different AIs to collaborate during the learning process itself, you create a team where the whole is truly, genuinely greater than the sum of its parts. It's not just an average of experts anymore. It's a real synergy of their combined knowledge.
And that's why this should matter to all of us. This technique isn't just for predicting energy use. It's a powerful new playbook for building AI teams to tackle any complex problem you can think of. From predicting the stock market to diagnosing diseases, it is a whole new way of thinking about the problem.
So that leaves us with one final, big question to think about. We've seen that one smart manager coordinating a team is way better than just stapling together 10 separate reports. So where else is this idea of collective training about to completely change the game?